Here. I'm just going to introduce this real quick. Let me just check. If I'm talking to different unit, so you're going to you got to make sure you stay on top of it, or else it'll bite you after a while, okay? So I hope you did a few questions at least. So let's go to page 9. And the first order of business is for every single player, right? We have kept track of 10 games for each player. And in this case, these represent points, right? We don't even know what sport this is. Maybe basketball. I don't know. Is that realistic for basketball? No, it's a little high, right? Yeah. Maybe Michael Jordan would score that many points. So that's beside the point. What we're going to do here is for every player, we're going to find the range, the mean, and the standard deviation. Okay? And we're going to use them later to answer the questions that follow below. So how do I do this? If I have a bunch of players in this case, I would put this into L1, right? Anna's scores into L1. I would put Patrice's into L2, Morgan into L3, Paige into L4, Star into L5. Okay, so that's how I would approach this. And then I'll do one with you. Jed, could you reach the lights for me? Thank you. Appreciate that. So stat, edit, clear whatever you have in there. So go to the top, press clear, and then enter. And so let's start with Anna. Make sure you take your time, because it's very frustrating if you do this whole thing and you get it wrong. And I noticed that my last entry is the 10th value, and that's perfect. Just a quick check. Okay, we're good. So I'm just going to go ahead and find Anna's range, mean, and standard deviation. So I go stat, calculate, one variable stat, and then you got to feed it. You got to feed it, in this case, L1, correct? Okay. So I'll write down the mean. So her average score per game is 36.7. Okay. Standard deviation. Which number is the standard deviation again? 6.2 or 5.88? Because that's the one students mix up all the time. It's 5.88. Okay, this one right here. And the range, how do I find the range again? Scroll down on your screen, and you'll see the lowest and the highest value. So all you need to do is subtract them, right? So you go 45 minus 27, and that gives you 18. That's just Anna. Does the standard deviation mean anything right now? Not really. Not yet. Once we start seeing the standard deviations for the other players, that's when we're going to start to see, oh, okay, like Anna's is low or Anna's is high. Like we'll start comparing that, okay? So I did the first one with you. If you want to do Patrice next, all you need to do is go to Stat, Edit, and go to L2. Type in all the scores for Patrice into L2. Repeat the process. Find the range, mean, standard deviation for Patrice, and move through the whole table like that. And then we're going to use our findings to answer questions A to D. Okay? After you've done that. So go ahead and do that. I'll come around in a bit. If I see that you're a little lost, I'll help you. I'll throw you a rope or a buoy or something to hang on to, and I'll pull you back into the boat, right? So I want you to fill this in for now. If you want to already answer A or think about A, that's good. Here we go. That's what you should have in your table. Okay. So check to see if that's what you have. If not, I would just write down what I have for now, because I've used it many times already, so I'm quite confident that my numbers are correct. Many students have corrected me over the years, so then my answer key is perfect after a while. Okay, what do I want you to observe, okay? I don't know if you've ever noticed, but a lot of times folks are concerned with the average, right? It's like, what's your average? Basically, when I give you your final mark, when I give you your mark on the report, all you see is the average. Average tries to take everything you've done and put it in equal buckets. It spreads out everything you've done and put it in equal buckets. So it's kind of saying on any given time, this is what you expect to score, right? But it doesn't tell you whether or not sometimes you come in with your A game and you score 99%, and then other days you come in with your B game and you score 50, 90, 50, 90, 50. That is inconsistency, right? So if you want to know more about the player or the student or anything like that, or the class, you want to expand, and I asked you to find the range just to see how it's related to the standard deviation, okay? But look at the standard deviation here. The lowest standard deviation is who? Who has this lowest standard deviation? It would be Paige, correct? That means that Paige's scores overall are fairly close to her average, meaning she's pretty consistently scoring around this, right? And look at her, what's her average, 33.9? Look at the scores. They're actually all fairly close to 33.9 if you look at it, okay? Who has the highest standard deviation? Morgan, right? So her scores are not as consistent, and if you look at the scores, look at that, there's a 19 there, there's a 48 there, right? So 48, and all of a sudden 19, there's a 21, it's all over the place. So a high standard deviation tells you inconsistency. There's inconsistency in your data set. I can guarantee you if you were to do line plots for every single player, you would see that. You would see the spread for Morgan, and you would see a pretty clustered data set around the average for a Paige. Okay? Another thing I want you to notice, high standard deviation is directly related to a high range. Why is that, Mr. Dirksen? Because if your range is high, if you have your number line, that means that the low and the high are spread out quite a bit, right? So that's a 29 range for Morgan. So it gives us a little bit of a hint already that the standard deviation is probably going to be high as well. Who has the lowest? Paige again, right? Her, literally, if we were to do a number line, the high and the low is just 0.83 of a difference. There's not much you can be, right? If you take the lowest and the highest, that means there's nothing beyond those points on the low end or the high end. So you're guaranteed that all the points are between here, which gives you an indication that it's going to be clustered. Does that make sense? I hope that makes sense. Yeah. Okay. So that's something I want you to remember. Okay. So as a coach, what do you want? What would you prefer? A consistent player or a player that every once in a while does really good, but then also has like games where they just bomb it? You probably, if you were like a pro team, right? Bombers, let's say, or Jets, you're going to look for consistency, right? Because consistency is something that teams look for mostly, and it's easy to bring that player up a little bit, right? Because you're pretty consistent, let's just work on certain things and improve your skills, right? Okay. A, which player would be considered most consistent? Which player least consistent? Explain how you know. So you can't just tell me, I think it's so-and-so. You need to tell me, how do you know for sure? And the answer is standard deviation. Okay? Most consistent. Consistent. would be Paige. Okay? Paige, since she has the lowest, since she has a lowest, or the lowest, I'm just going to write down SD to shorten it so we have enough space for the rest. Since she has the lowest standard deviation, which indicates consistency. Write your heart out on these questions, okay? Most of the time, she scores close to her average. Sorry about that. It's very, very tight there. I know that. I hope you can read that. Okay. And then least consistent. You would essentially say exactly the opposite of what you just said for Paige. But you would say it would be Morgan, since she has the lowest, highest. Thank you. Highest standard deviation, indicating variation / inconsistency. I hope you can see that. It's not the greatest. But Mr. Carrington was making fun of me today. It's like, see, old technology works with or without internet, so I was worried that this wasn't going to work, but I got it to work. He loves his overhead projector, and I gave mine away this year, so I was worried there. Identify the player with the greatest average score. Would you consider her being the best player? Explain, right? The greatest average is for 36.7, right? That'd be for Anna, right? Is achieved by Anna. Okay? Her standard deviation is fairly high compared to the other players, right? I would say it's right. Morgan has the highest, and then there's Anna. So I would say her standard deviation is fairly high, which shows a lack of consistency. Shows a lack of consistency. Therefore, I would not consider her as the best player. Okay, and I know this is a little abstract, like we don't have footage of the player, okay? So it's sometimes players just, like there's a lot of reasons sometimes why they don't score well in a game, right? But if all we have is data points, and that's what we have to make our decision. Which player has the potential to score the least amount of points on any given game? Okay. Which player has the potential to score the most points on any given game? You can say that, you look at the scores. I think Morgan scores the highest ever. If you look at all the scores, 44 is the highest. Oh, there's a 48? Oh yeah, Morgan, sorry. But it's Morgan nonetheless, right? So Morgan has the potential to score the highest. What about the lowest? There's 19 here. So Morgan is the highest and the lowest. Yeah. Morgan has both the highest score, which is 48, and the lowest, 19. Okay. This explains the high standard deviation slash range, right? Both of them. Sorry, let me bring that up a little bit. That explains the high standard deviation and the high range. Okay. D, if you were the coach, which player or players would you choose? Base your decision on what you know about the standard deviation. I would say and the mean. Can we add that here? You do want to look at the average, of course, but not exclusively. We're a bit more now looking deeper into standard deviation as well. Okay. All right. As a coach, you want to look at players with a high average and low standard deviations. So I don't know if that makes sense. You want a relatively high mean, but you want a lower standard deviation. So let's see here. I think this would be there's no perfect answer, but I would say Patrice would be a pretty good choice. Like if I look up here, right? Patrice, if you look at the averages, Patrice has a pretty high average and a fairly low standard deviation. So that'll be one of my picks in this case. And then I will look at, you could go with Paige, but the average is low. If you go with Star, the average is a little high and the standard deviation is not the highest for sure. So you could say, you know what, you could have an argument to go with Paige or Star. It's up to you. I'm going to go with Patrice and Star in this case. Okay. Patrice and Star would be good candidates right? So Patrice's mean is 36.4, standard deviation is 1.5, whereas Star's average is 36.3 and her standard deviation is 3.35. We don't have units right now for those, so obviously we would just think that they're points. So maybe I should have clarified that, points. And it's okay to have decimals because it's a measure. We're trying to measure one against the other. Okay. All right. Let's go to page 11, and then I'll move on with today's lesson on graphing these things. Okay. Can you quickly find the mean and standard deviation for each unit test? There's two classes, or two tests for a class. Go to page 11. Calculate the mean and standard deviation for both unit tests. So do it for this and do it for this as well. What I want you to do moving forward, what does it say? Mean and standard deviation, yeah. I want you to do this, mean, standard deviation, and can you tell me n as well? I'm going to start looking for that. N is the number of scores that you've entered, right? So you do that for both set. and then we're going to answer B. Did the class perform better on Unit 1 or Unit 2 tests? Justify your decision. So we're considering all these scores to be in as a percentage. I know I only asked you to figure out the mean, standard deviation, and the number of. How many that would be 6 times 5, right? So 30 for each. Sorry, 5 times 5, which is 25 each. So I'll add that here. 25 tests, right? Or 25 students. It's up to you. But I just want you to be aware of that. But these are, so if you look at the average is exactly the same for both tests. But what do you notice about the standard deviation? Way off, right? Like it's, so the class did better here. As a teacher, it would be like here, because there's more consistency. Most students are going to be closer to that average, whereas here, students are a bit further from it. So if you want to have a bell curve, right? If you had the same bell curve on the same line, they both have the same average of 71.2%. Okay? But which one is going to be steeper? This one, right? It's going to be steeper. So you would have, I always start here, and then I go down like that. This would be, I'll use a color for it in a bit. Whereas for the second class, you'd be lower somewhere here, and then it just goes flat like that. Okay? What color should I use? I'm going to use green. Green. So that's that one. I'm going to use pink for this one. Okay? So I will ask you to do that quite often. Like, just give me a sketch. What would the curve look like for both? Okay? So just so you know, that's what I do. And here's a little bit of a write-up. Try to summarize, right? Both tests have the same overall average mean. This could possibly indicate that students perform similarly. However, when we look at the standard deviation, we can clearly tell that students' scores were a lot closer to the mean in test 1 due to the lower standard deviation, right? Test 2 had a much greater standard deviation, which indicates that the test scores are more dispersed. Okay? One more time. If I look at it as a teacher, and I'm like, whoa, right? My standard deviation is double, right? More than double. I'm like, I'm concerned because I'm like, it seems like maybe my teaching wasn't great, right? Because some students didn't get it at all. Some students did really good, but there's a spread, right? I would like something more consistent like this. Okay. So that's that. We're gonna stop here.